Welcome everybody to Sustainable River Basin Management, Module 4.1, Part 5, last part of. Now we will continue on the subject water allocation and water pricing. This time let's talk about uniform volumetric charges, or the same term is constant volumetric tariff. This means that we have here our volumetric consumption in cubic meter, and here a price, and this is a linear relationship here. It could be a steeper relationship or it could be more flattened, but in any case it is a linear relationship here. And this is all consumers, which means it could be a domestic or industrial or commercial users, are supposed to pay the same unit rate. The water bill is directly and linear to the quantity of water consumed. This means that people can limit their water bills, reduce the costs by reducing consumption. And very often there's a fee for the use of the piping system that can be applied or added to this. Means that the costs here, the line would not start here at zero, but it would start somewhere here at this line and then be linear here. Now, what are the advantages or disadvantages of the system? In the first place, it treats water as a commodity. It treats water as a good. And we have talked about this earlier, that water is an economic good. It's an economic asset of national interest. So in this volumetric tariff, constant volumetric tariff, it is for the first time treated as such and accounted for fully. So water conservation measures have a direct influence on the consumer's water bill, which is an invitation to each and everybody to try to save water. It, however, ignores the needs of the poor. Those who cannot afford, they will have no alternative to cope with the water prices. So institutions that need a lot of water will have accordingly a very high water bill, which may not make it very attractive to be operating in such a high price region. And this, in some of the cases, encourages those institutions to move outside the country, especially those high water consuming industries would leave the country and settle somewhere where the tariffs are more in favor to these industries. Now let's look into the water pricing example of Germany. The case of Germany, there's a policy of full cost recovery, and it charges for both drinking water and sewage, whereby the drinking water amount is set equal to the amount of outgoing sewage, and that's how sewage will be measured indirectly by metering the drinking water consumption. Now, how is this full cost recovery be achieved? There's a two-part tariff. It consists of a fixed charge plus the constant volumetric water use charge. So those charges for drinking water are influenced by topographical and geological conditions, where the water has to be taken from water reservoirs, from groundwater and so on, the settlement structures, the efforts in source water protection, and the maintenance and replacement of distribution networks. Very often, however, we also see that the revenues produced or obtained by charging for drinking water are also used to fund communal budgets, to top up communal budgets. So it's not simply a full cost recovery, but very often it is also a revenue generation which is being achieved and funded for. Now, Let's look into the projected water use in the case of Germany. The forecasted and observed household water demand from the year 1975 to the year 2010 here. What we see is that the projections were all forecasting a steep increase in the water consumption from the 1970s to today. Any of these research institutions or academic institutions actually projected a continuous steep increase in population number, and in that way an increase in the household water demand as living conditions continue to improve, as the stability, economic stability improved. This was the forecast. What actually happened, this is showing us the actual observed household water demand. There was a tipping point here in the 1985, from which onwards the amounts of water used per year and household decreased continuously, and this decrease is continuing till today. Now, Germany has the second lowest per capita water use of an industrial country right now, just after Belgium. And this is quite remarkable. We'll look into this, why and how this happened and what the consequences are. Now, Germany has invested into public water supply from the 1990s to 2010, several billion euros. This is a graph showing us the expenditures in pipe system, in water abstraction and treatment, in storage facilities, and then in meters and sensors, monitoring systems, IT technology, and alike. What you see is that this budget always fluctuates a little bit, slightly decreased, but overall actually was kept fairly constant. And the priorities here shifted and changed as political changes took place, and also some of the natural disasters like the floods, major flood events struck the country. But what we can see that there's a huge amount being invested into the water sector over the last 10 years, which also corresponds to the fairly low amount of water that's been lost through the distribution system. Now, this is one side. The other side is that at the same time, water-saving technology has become common use in most of the households in Germany nowadays. This is a graph that was produced by a university in Germany, which shows us the year 1970 up to measured around 2005, and then the consumption in liter of these household devices. First a dishwasher here, and the rectangles here, or the squares, a washing machine. And what we can see is that actually the consumption decreased by a factor of 3 in those years. So, and there's certainly a limit being reached up to which point we can reduce water consumption of these devices to still be effective. But this change has been quite important, and simply is a technology move and a move in terms of efficiency, not only in water but also affordability by the household. So it's usus to have those devices, and in that way people can be much more sensitive to water consumption as well as to prices in general, costs in general. Now, this is one. The other one is the spatial distribution of the people who need drinking water. and who depend on the infrastructure into which the government has invested so much. Here we have a map of Germany, and we see population changes. This is population changes here. The scale from blue, minus 15%, to dark red, to more than 15%, above 15%. And we see here a major break going through the country. The change monitored here from 1990 to 2004. We see here that we have major parts in the east which are blue and so show a negative change, and then we have some major dark red areas in West Germany where this increase, the population increase took place. So what we see in those years is a major migration from east to west, and from any part of Germany towards the industrial hubs around Munich, around Berlin, around the ports and so on. Now, when we look into the forecasts of the changes to be seen between 2004 and 2020, then we still see this sharp division here, but it's actually expanding. The blue parts, light blue and dark blue parts, which means the sharp decreases in population rate, expand, and the boundaries are not as sharp anymore as they were on this first map here. And what we see here is two things. One is a negative population growth, and we also see that people are actually settling in other countries. People concentrate in very few industrial hubs or economic hubs, but there's also a major component of the population actually leaving this entire area and moving to other countries, maybe in Europe or even outside Europe. So this has a major impact on the water infrastructure, the infrastructure that is in place and has less people to serve. So on one hand side, we have the availability of technologies. On the other hand, we have demographies, the migration patterns, the negative population growth observed in Germany, and then we have people's behavior, the choices people make. They may migrate, they may save water, they may spend money in water saving technologies, they may save water as much as they can wherever not watering their gardens or washing their cars at home, things like this. So what we see is something that we can call a systems trap. And this is, on one hand side, the fee structure for water has been an incentive for water efficiency. This is what was wanted very much. But the current supply and distribution systems cannot afford more water savings. This is the trap in which we are right now. And the redimensioning is only economically feasible in conjunction with the replacement or renewal of expired parts. So we cannot remove or decommission parts of our water supply infrastructure unless it can be paid for, unless it pays for itself or is economically feasible. So, and this is actually putting the water service providers into a position where they have to supply, even they have to flush the system to keep it functioning under good conditions, whereas on the consumer side, people are not ready to pay more or consume more water to maintain the system in proper function. Now, it's what is reflected in the water pricing is that the average household in Germany consumes about 80 cubic meters per year. 1 cubic meter of drinking water costs it on average about 1.69 euro in 2013. the water connection fee, which is a fixed charge, costed on average 70.98 euros per year. So there are very high operating costs, which is very high fixed costs, amounting to 85% of the charged water price. And 15% are charged based on water use only. So the 15% is what is being influenced actively by the water consumer, whereas the rest is imposed by the high operating costs to maintain the structure of full cost recovery. And then we have 91% of the revenue earned from water use charges on the other hand, and 9% of revenue earned from the fixed cost charges. So this shows a little bit of what problems, what the system's failures are, and where major restructuring has to take place in the near future to cope with these changes. Now, let's step out of these tariffs in the water charges and look into another type of water pricing, which I had mentioned in our introduction. Let's talk about tradable water rights. Where does it come from? It departs from the valid thought that environmental degradation is taking place whenever we use water. There will be water pollution, there will be a resource depletion taking place as a result of some economic activity. And the fact that a substantial part of the costs of the economic activities is not paid by the responsible actors, those who run the economic activities, brings 2 points together which can be structured in a so-called tradable water right. Those costs caused by these economic activities right now who impact on the environment are generally transferred to the general public in the form of environmental damages in the extremes, in the form of security risks such as conflicts, health risks, or long-term climate changes or climate risks. And this is just an example of some mining going on which has disrupted a large part of the surface here, removed fertile soils, removed forests here, and has polluted, poisoned entire river systems. This is an example where some benefit from this mining activity and are not taking care and not actually charged for the pollution, because that pollution has been transferred from this site to somewhere far away from where these economic activities are going on. This is just one example. We could have taken any other example here. Now, the tradable water rights actually start from or take into account an overall level of allowable pollution or abstraction that is established by one responsible authority. This is the departing point. So at some point somebody has to define what is an overall level, what can the world cope with, or what can the specific river basin cope with, and what is an allowable pollution or an allowable amount of abstraction. You can see already that this can be a very less scientific discussion and less science-based and very much driven by interest groups and very much driven also by political powers. And this is exactly also what we see in terms of the climate change discussions at the moment going on. So the same problems apply to the case of water, whereas water can be, we can apply such a scheme just in one catchment. We could apply it in larger catchments also, or we could try to apply something at a global scale as well. And then there must be some responsible authority being set up that is accepted by all of these different parties potentially involved in these water right trades. Now, the allocation of certain amounts of water pollution for a certain time or a certain period are conducted by issuing permits. So this means you have to be a registered water user or a registered water polluter, and for that you receive a permit. You pay for that and you receive a permit that is valid for a certain time and or a certain period during a year. And then enterprises that keep their emissions or their water abstraction, their usage below the allotted level, they may sell or lease their surplus permits. So it's a market, it's an economical mechanism that allows trade of the permits, which can be sold to a firm that requires additional permits to pollute more water or to abstract more water, or to use those as offset excess emissions in some other parts of their facilities. So this is where the economic cycle plugs in, and where also competition can take place. Now, this creates the development of water markets, but also it creates a market of pollutants or pollution emissions that are traded essentially. Now, you may now ask, what is the difference between a charge or a tariff or the tradable water rights? There are differences. So those charges do not impose a fixed level of consumption and pollution, but rather create an incentive for less consumption and less pollution by providing economic benefit. And we have seen examples just now. Whereas on tradable water rights, you have a certain permit, and if you do not use that permit, it's a waste of money in this case. You are registered maybe as a polluter, whereas you are not really polluting, and you may be punished for not polluting and not using your permit, or you may be punished for not consuming or not abstracting the amounts of water that you were allotted to. And so it's not generating a positive economic outcome and positive economic benefit at a larger scale. So the monetary resource transfer is private to public because the charges are levied by the state. And this is opposite to the private to private relationship between the tradable water rights. So this also secures some transparency, one would assume, and some balance also of social interests, overall poverty alleviation interests or socio-economic development interests of the country when charges are set up versus the private-to-private interests, which are purely profit-oriented schemes. Now, the costs on public and industry are more explicit compared to the tradable water rights. This is because the users do not perceive them as being rights to pollute or use, but they rather see this as a restriction. That's again a different mechanism. It's when we exercise a charge, an emission on effluents or an emission on emissions, then this is rather a restriction or an enforcing of restrictions rather than inviting somebody to use it up to the upper limit that somebody has been allotted to. Also, the charges do not adjust automatically for inflation, and this may be a negative aspect in this case because you remember that infrastructures, water services have to be funded and have to run economically. There must be a possibility to invest in the maintenance and expansion and upgrading these infrastructures, which may not be given if some of the economic inflation processes are not accounted for in the charges. It does not happen automatically. The charges are less susceptible to strategic behavior of firms. So if one firm holds a great part of available permits in a water rights system, the activities distort the price of permits entirely. It creates a monopoly situation, which can easily happen in water trades. As you remember from our virtual water trade discussion, that there are only a handful of corporate companies dominating and controlling the entire water bottling business. And so imagine applying tradable water rights as the only mean of controlling water abstraction and water pollution. This can easily become a system that runs completely against meaningful water management objectives, sustainable water management objectives. Now, before we conclude for today, I want to suggest to you to find out how subsidies work, especially in the water sector. We have not talked about subsidies. There's a reason for why I did not underline them especially, but you should find out about subsidies, what the disadvantages are and what advantages there are, and what maybe are linkages between some other subsidy schemes which influence the water sector. And you could also find out a little bit more about advantages and disadvantages of tradable water rights as compared to the charges and the tariffs. We have mentioned many of the advantages for charges and tariffs, and you may discover more of the good points of tradable water rights and think whether this could be a mechanism that should be extended more in our real water management operations. With this, I thank you for your attention, and I see you next time again.